My dear students and learners, welcome to video 1 of Engineering Thermodynamics. I am Dr.SUJA, Assistant Professor of Mechanical Engineering Department, Tandai Periyar Government Institute of Technology, Vellore. And I am going to continuously give the videos for the course Engineering Thermodynamics in the Anna University Regulation 2017 with the subject code of ME8391 for third semester second year mechanical engineering students. This is one of the fascinating and hottest topic of mechanical course. There are 5 units, you know already, as you have completed the first year. In as other courses, here also you have 5 units. The first unit comprises of basic concept and first law, in which you are going to cover all the basic concept of thermodynamics along with the zeroth law and first law of thermodynamics and its applications. Course outcome of unit 1, this fundamental concept of thermodynamics, is to formulate first law of thermodynamics for open and closed systems. And to achieve this course outcome, the learning objectives are to define the fundamental concept of systems, properties and processes, and to contrast or differentiate open, closed and steady and unsteady processes, explore zeroth law and first law of thermodynamics and its applications, and finally to develop the energy equations for simple thermal machineries. Fundamental concept of thermodynamics is a topic today we are going to learn, and I am going to cover here in this video what is engineering thermodynamics and its applications, energy transfer and its effect on properties, various methods to analyze the systems, basic terms and terminologies, types of systems and surroundings, and substances. Okay. What is engineering thermodynamics? It is a very important and indispensable topic in the domain of mechanical engineering branch. Is physics, which deals about the effect of temperature, pressure and volume on the physical systems, which is made up of substances at the macroscopic scale by analyzing the collective motion of their particles in a mathematical model. That is, this is also the physical system, whatever we are dealing and physically viewing in day-to-day activities, okay, which is working by the input of temperature or heat. Okay. And then what is the various changes which we are taking in that system, which is converted to useful work to the human community. We are going to convert all the activities or the output of the heat energy to work energy in terms of mathematical model or simple energy equations. We are going to study about two energies. One is heat, another one is work. Okay. Only throughout the course we will be studying about how heat will be converted to work. Okay. Heat is also a type of energy and work is also type of energy. You know very well, and you would have studied about these various kinds of energies, and you know very well that one type of energy can be converted or transmitted to another type of energy, and energy can neither created nor destroyed. Energy conservation equations and what is energy, what energy you have, so many terms you would have heard about energy. Like work, you know about what is the power of work. Okay. What is the purpose of various engineering applications or devices, instruments is nothing but they have to work, they have to give some output to us. For getting that work energy, various resources can be let into the system as an input. Here we are going to give or supply or take heat only as a input energy. Okay. So this subject deals about heat energy and work energy. Very best example which explains what is engineering thermodynamics is our body. Okay, what you are taking as a food for breakfast, lunch, or dinner, or beverages, might be in terms of grains, vegetables, fruits, meats, various kinds of substances, or things which you are eating, that is converted to power or work energy in terms of your physical movement, and the remaining waste is coming out in terms of a liquid or solid waste we are letting out. Okay, so here input is your food items, output is energy or work which is coming out from you. Okay, what is in between this food and energy is the inside thermal temperature or existence of the heat energy inside your body. You know very well that if you don't have heat sufficient amount of prevailing of this 97.7 degree Fahrenheit of temperature, means then we cannot even we could not be considered as a human being, right? So that much this existence of this temperature is very much essential, which is not only for our life but also for conversion of that food into energy. Working of all the organs takes place only because of this temperature. Okay, that much the heat energy is important. Why we are considering this human being, at least this small human being? You just take a mass earth or universe, earth revolution, rotation, everything is existing because of the solar energy or heat energy supplied by the sun is a source of the energy. You would have studied in your schooling itself, right? So heat energy, wherever it's supplied, it has been supplied, it would be converted to work. The application of this thermal application or thermodynamics is in the various very important domains like aerodynamics, power systems, internal combustion engines, all types of refrigeration systems. Everything is being used using this thermodynamics concept. Okay. Here a very simple example which has been shown, that the air balloon, without the supply of heat energy or gas, hot gas, it would have been in a like a cover which has been on the ground as a bed sheet, like, okay, after it has been filled, its total shape and the volume and its position, everything has been changed. Why? Because of the hot air, the thermal supply of the thermal energy into this balloon changed everything, right? So heat is doing something, right? That how it is doing so many miracle things. The improvement and the various design development and improvement research is very much uh, going on in a peak, very much essential for innovative devices which are going to do very spectacular improvements in the life of the human being. Okay. What are the various methods to analyze these systems? We can take macroscopic and microscopic, two types of analysis, in which microscopic analysis is consists of it comprises of a large number of discrete particles, the average behavior of all the huge groups of small and individual particles to be considered. And since number of molecules are very large in number, since we are considering it in the microscopic level, it requires advanced statistical mathematical methods. Okay, large number of variables are involved to describe the systems. Okay, So it is in the second level, or we can take it as a research level or PG level study. So we are skipping this microscopic approach and we are coming to macroscopic approach or macroscopic or classical approach, in which the attention is focused on a certain quantity of matter. Okay, we are not taking into account of each and every molecule, but instead you are taking as a bulk. Okay, the mathematical formulae. Simple mathematical formulation equations is used to analyze the systems, and few properties are only needed to describe the system. So better to have macroscopic or classical approach is only studied in UG thermodynamics. Okay. The basic terminologies. You know very well, when you are studying a new subject or course, we should learn the new terms or technical terms related to that particular course. Okay, so you will be using this system, surrounding, boundaries and all for the entire course of this subject. Okay, so system. What is system? Is nothing but a quantity of matter or a region in space preferred for analysis. Where you are doing the analysis is only system. Outside the system, everything is considered as a surrounding. If you are considering a glass of water, that is your system. Outside the covered portion, apart from the glass, is considered as surrounding. A boundary is a real or imaginary surface that separates that system from its surrounding. The glass is separated from the surrounding is only by its outer cover area. Okay, so your system is glass of water. Okay, so here you can see what a system. The gas inside this piston cylinder arrangement is the gas is the system. Other than the system, outside is all in all the four directions. You can able to see the surroundings and the covering of this piston and the cylinder surface, outer surface, is considered as boundary. Okay, system, boundary and surroundings. Okay. We have three kinds of systems, three types of systems. The systems can be classified into closed, open and isolated system. It would be so interesting to know, by the name itself you come to know closed. It will not allow the mass, any mass, to enter into the system. So only energy can transmit in or out of the closed system. Open means it is open to both energy and mass can cross the boundary of the system. And you have to remember one thing is, most of the engineering systems are coming under open systems. Isolated means neither energy nor mass can cross the system, and purely it is a hypothetical system, that is imaginary system, because nothing is in the world is isolated. It should have some sort of contribution to or into the system with the surroundings. Okay, so this is only a hypothetical. A best example for this isolated system is a universe, Earth. The planet can be considered as an isolated one, but that is also not like that, but still, okay, to some extent we can tell. Okay, here you can see the kinds of boundaries, or the types of boundaries can be fixed and movable, and types of systems are closed, open and isolated systems. And types of exchanges, what we are dealing is about exchange of energy and exchange of matter. Here there is isolated systems don't have both the energies. Here both the energy transfers. Here closed system is energy transfer possible and not mass transfer. Here mass transfer and energy transfer takes place. Okay. So thank you for patient listening. Learners, let me join in video 2 in the of this thermodynamics course. Okay, so here in this first video, I described you the important terms and the importance of engineering thermodynamics for second year mechanical engineering students. Okay. Thank you once again.